This lesson will teach me to dilate a figure when given a dilation rule and write a dilation rule when given a pre-image and image. Dilation is defined as a transformation that can change the size of a polygon but leaves the shape unchanged. It stretches or shrinks the original figure, and it is not an isometry or a rigid motion, because an isometry or a rigid motion are defined as something that does not change the shape. Center of dilation, a fixed point in a plane about which all points of a figure are dilated. The center can be at 0, 0, or a point of the pre-image. Let me take a second to go over some of this vocab. When we talk about pre-image, we're talking about the original figure. When we discuss the dilation, we're talking about the resulting figure. So we have dilation, center of dilation, and then scale factor. Scale factor is the ratio of corresponding sides of two similar figures. The scale factor measures how much larger or smaller the image is from the pre-image. To find the scale factor, you take the length of the image, which is the resulting figure, over the length of the pre-image, which is the original. Notice the notation. The prime notation is for the resulting figure, and the normal, AB, is for the original figure. When you take the length of the image over the length of the pre-image, you will get a fraction. We use the letter n to represent scale factor, n for number. So when the scale factor n is greater than 1, the image has been enlarged or stretched. Think about the idea of having a scale factor of 2. 2 would mean that the image has been blown up so that it's twice as large. Think about getting a number such as half, something that's between 0 and 1, would be a reduction, as the figure would be half its original size. What if you have a scale factor that is equal to 1? It's possible, but doesn't necessarily happen all the time. A scale factor of 1 would mean that the figures are congruent, that they haven't actually changed size. So dilation rules can be done in different ways. Different textbooks do it different ways, different tests, and different teachers. We can do it in words. We can state to take a figure, triangle ABC, and dilate it by a scale factor of 2. So looking at this diagram, and all three of these rules say the exact same thing about this diagram. We have triangle A, B, C, and it's telling you to dilate triangle ABC by a scale factor of 2, meaning that it's going to get larger. These words mean the exact same things in ordered pairs. This x, y stands for an ordered pair, and it tells you to take an ordered pair and to change it by taking 2 times the x value and 2 times the y value. So again, you're seeing that idea of a scale factor of 2. Each ordered pair is getting blown up by 2. Or, and this is my preferred notation, it's called function notation. This capital D stands for dilation. This 2 is the scale factor, and this right here, it's triangle ABC, but whatever is in the parentheses is the figure that's being dilated. So in looking at these examples A and B, it's asking for the center, it's asking for the type of dilation, scale factor, and the rule. The center of dilation for this particular example is point E, as it's a point on the pre-image. So the center is E, or you can list it as -2, -2. How to determine if it's an enlargement or a reduction? Find the original E, F, G, H, and then find the prime, E prime, F prime, G prime, and H prime. Notice that from the original, it went down to the prime, so this has been a reduction. In order to find the scale factor, we have 2 different ways to do it, and we'll do one in problem A and one in problem B. Notice the size of the diagram. This one here has a side length of 2 and a side length of 3. The purple one has a side length of 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. If we started with a figure with a side length of 4 to get down to one with a side length of 2, and to start with a figure with a side length of 6 to get down to a side length of 5, Each side length was reduced by a scale factor of half because it was 2 over 4, it was 3 over 6, which reduces to 1 over 2. Although I'm sure most of you could have figured that out without needing to set up the fraction. The rule: because a dilation has been performed, we have a capital D. This scale factor comes next, followed by the shape that received the transformation. Over here to letter B. Here the center of dilation is actually the center of our shape, as both the figure and the preimage and the image are centered around it. This is an enlargement or a reduction. So let's find A, B, C is our original. A prime, B prime, C prime is noticeably larger, so this one has been an enlargement. For problem A, we were able to count the boxes to find the side lengths and compare them. In problem B, that's more difficult because these side lengths are slanted. Instead, let's look at the ordered pairs. To find the ordered pair of A and compare it to the ordered pairs of A prime. From A to A prime, all those numbers have been multiplied by 2. Look at B. Look at B prime. These numbers were multiplied by 2 to get these. Make sure that it holds true for C, and it does. So the scale factor here is 2, meaning that this is a dilation with a scale factor of 2, and the figure that was dilated was triangle A, B, C. Problem C and D, asking the same thing. It's asking for the center. Similar to problem A, the center is the corner of the preimage. There's no ordered pair, so we can just call it A. Has it been an enlargement or a reduction? A, B, C, D is here. A prime, B prime, C prime, and D prime is a larger figure, so this one is an enlargement. For the scale factor, compare the fractions. We have the length of the original over the length of the preimage, leaving us with a fraction. Whoops, I think I did that the other way. We need it to be 4 over 2, because if this is an enlargement, that number needs to be larger than 1. So this was blown up by a factor of 2, so we have a dilation with a scale factor of 2, and the shape that was dilated was shape A, B, C, D. Over here, letter D. Center is this point C, which is why it's kind of capital, it's in the center. I don't know what its ordered pair is. Is it an enlargement or reduction? E, F, G, H is out here. E prime, F prime, G prime, and H prime is significantly smaller, so this one was a reduction. The scale factor. Because it's a reduction, we need a number that's somewhere between 0 and 1. So think about putting these. It would need to be 2 over 8, which is 1/4. If you would have goofed them up and accidentally written 4, similar to how I did in problem C, you would have realized that this means that the shape is getting bigger. We need a fraction that represents that the shape is getting smaller. We write the rule with a capital D, the scale factor, and then the shape that's being dilated. And lastly, for 4A and B, it asks for what are the coordinates of the vertices of capital D stands for dilation, 2 is the scale factor, so that means it's all being blown up by a scale factor of 2. So it's asking what are the coordinates of the vertices of triangle PGZ after a dilation with a scale factor of 2. We'll try point P is over here at 2, -1. This is 0, -2, and this one is -2, +1. So P prime, after a dilation of 2, would be taking this ordered pair and blowing all of it up by a scale factor of 2. It would be at 4, -2. Do the same thing for point Z. Z prime, if it were blown up by this scale factor of 2, would be -4, 2. And point G, if I took point G and multiplied it by a scale factor of 2, then it would be at the point 0, -4. Problem 4B, it's asking for what are the coordinates of triangle PZG again, but this time the dilation is a factor of 1/4, meaning that this time it's getting smaller. So if we take these exact same ordered pairs, and if we were to dilate all of them by scale factor of 1/4, you'd be multiplying these ordered pairs by 1/4. Your calculator might be helpful for those of you who may not be strong at basic math. I'm going to call this P double prime, as I've already used P prime. So if I were to take coordinate of P and multiply it by 1/4, I'd be at 1/2 negative 1/4. My Z prime, double prime, as I've already used the prime notation once. Multiplying those by 1/4, I'd have negative 1/2 and positive 1/4. And lastly, G prime. I'd have 0 and negative 1/2. This would be harder to graph, but it would be doable. So the idea of it here is that the capital D stands for dilation. This small number here is the scale factor, and that's the number that tells you how big or how small the shape is going to become. And the figure being discussed in the parentheses is what's receiving the transformation. We're going to use prime notation when the shape has been changed once, and we're going to use double prime notation when the shape has been changed for a second time. So that concludes the video. Please let me know if you have any questions. Thank you.